Okay guys, 3.2 video 2 starts out with our basic property of logarithms. And so for any base where b is greater than 0, but it's not equal to 1, then these properties will always be true. And so you know that log base b of b will equal 1, log base b of 1 equals 0, log base b of b to the x equals x for any real number x, and b raised to the log base b of x will always equal x. And just like I stated in the previous video, you can work all these out. The only one you really have to have memorized that you can't work out is going to be that number 2. And so you know though, when you go to set that up into exponential form, you have b to the 0 equals 1. Well, a lot of times that's going to be what you're solving for right there. And so you just got to remember, anything raised to what power equals 1? 0. So that's the only one that I really recommend you memorize. If you have the other ones memorized, great. If you get them memorized on accident, that's great too. But it's not something you have to go through and actually memorize, because you can work them out. Alright, so now that we got that, we're ready to move on then to example 4. So example 4, the directions are just to evaluate. And so on A, they gave us log base 3 of 3. So just like what we did before, we're in log forms. I'm going to set it equal to y. I know my base is 3, my x is 3, and my y is y. So when I set up an exponential form, my b to the y equals my x. Well, remember, if it doesn't have an exponent written, it's a 1. And so the one-to-one properties, so my bases are the same, so I can move them out. And so this has to be equal to 1. B is 5 raised to the log base 5 of 7. Now this is in exponential form, so we're going to set that equal to x, which, so since we have it, I'm going to label up here. So this is my b to the y equals my x. So I know that my base is 5. My y is log base 5 of 7. It's everything that's in the exponent. And my x is going to be x. So because we're in exponential form here and we're stuck, we're going to change to log form. So log form says you write out the word log, so log, of your base would be, which is 5, of your x, which is x, equals your y, which was that entire exponent, which is log base 5 of 7. Well, now when you look at this, you actually have log base 5 equals log base 5. That one-to-one property that allowed us to get rid of the like basis in the previous problem allows us to get rid of the log base if they're the same as well. Now, it can only be a log equals a log. You can't have a plus sign. You can't have any of that stuff. It has to be log base 5 equals a log base 5. If there had been different bases, you can't do this. If it had been plus 7 after the log, you can't do this. Alright, so once your log bases are gone, then that means that we're left with x equals 7. So we know that 5 raised to the log base 5 of 7 is just equal to the 7. Alright, so moving on, then we're going to talk about the domain of a logarithm. So, you remember we talked about, sorry it's kind of messy there, domain of logs. We had talked about in 3.1 about exponential functions, and under exponential functions we had said that their domain was negative infinity to infinity, but their range was from 0 to infinity. Remember, because they had that horizontal asymptote at y equals 0? Well, logarithms are the inverses, and remember, inverses means x and y switches, which means domain and range will also switch. So what's going to happen is our range for logs is going to be from negative infinity to infinity, and our domain is now going to be from 0 to infinity. Now I didn't write it here, but also remember that I'd stated that we had a horizontal asymptote for exponentials at y equals 0. Well, x and y are going to switch. So that means it's no longer going to be a horizontal versus vertical. It's not going to be, a horizontal asymptote, but now we're going to have a vertical asymptote. It's not going to be at y equals 0, but it's going to be at x equals 0. All right, but it's important to note, though, because the domain of a logarithm is from 0 to infinity, you cannot take the log of 0 or a negative number. So logs of 0 and negative numbers are not defined. I could only take the logarithm of a positive number. Okay, so let's look at finding the domain on example 5. So the direction says to find the domain of this function that I wrote down there. And so for y'all that are going through the slides with me possibly, just so you know, I haven't been saying what slide number I'm on, but just make sure we're same place. I am on slide number 10. And when I'm saying these slide numbers, by the way, guys, I'm using my student slides, not the teacher slides, because I did knock some stuff out of there. All right, so remember we said the domain had to be from 0 to infinity, but 0 is not included. So what that meant is that your domain, whatever you're taking the log of, has to be a positive number. So that means that this 2 minus x right there has to be greater than 0. And so if I move the x over, I find that 2 has to be greater than x. We always like to have x written first. It's not mandatory, but I just like that. So I'm going to flip it over, which means if 2 is greater than x, and x is less than 2. And so from there, I can write it in my interval notation, because remember, if nothing else, if you need to, use a number line. So here's your 2, here's your infinities, and you know it's less than. So we're going to go this away, and it's going to be a parenthesis. So I know that my domain then is from negative infinity to positive 2, not included. All right, and that is going to conclude video 2, and so we will be moving on to video 3.